Good morning, children. I hope you all are fine. See, we have done a lot in theory. Now it's time for practicals, and I hope you are studying properly. And please do study better. This is the only time when you can excel yourself. So we'll be starting with the experiment. And in grade 9, we are starting with chemistry experiment number 1. So the first experiment is solution, colloids and suspension. Before discussing the first experiment, let me tell you some basic points about your practical file, how to maintain it. So this is your practical file. This is the index page. This is right side and this is left side. Right side is what? Ruled, and left one is blank. Clear? See, left side, right side. Right side is ruled one, while left side is blank one. You will be writing each and everything here with pencil, while here with blue ink. You can underline it with pencil. Try to avoid even black pen as well, because in board exams even black is not allowed. Only blue pen and pencil is allowed. So please try to inculcate those habits only. Fine. Now see, at left side and right side what you will be writing? A will be written on both sides, right as well as left. Here with pencil and here with pen. Materials required both sides. Then theory will be on right hand side only. Then procedure. Then conclusion or result. And if precautions are there, then you will be writing precautions at right hand side only. Fine. At left, A, materials required. Observation table if it is there, along with the calculation. And then conclusion or result. Please mind it, if at right side you are covering suppose 3 pages, conclusion is written on 3rd page. And at blank side you are writing conclusion at 1st page. So please try to avoid such kind of discrepancies. Conclusion on both sides must be just opposite to each other. Fine. So these are some basic instructions. Then we will be starting the activity. Now the activity is to prepare a true solution, a suspension and a colloid. First of all, what is the difference between true solution, colloid and suspension? Now differentiate between these three. True solution is what? If you dissolve sugar or salt in water and mix it properly, then what will you see? A very clear solution. That is, why is it so clear? Because the particle size is very small. If particle size is very large, then suspension. If the particle size is in between true solution and suspension, like if the particle size is between 1 nanometer and 1000 nanometer, what is nanometer? 1 nanometer is equal to 10 raised to the power minus 9 meter. 1 angstrom is 10 raised to the power minus 10 meter. 1 picometer is 10 raised to the power minus 12 meter. And 1 micrometer is 10 raised to the power minus 6 meter. So, if the particle size is between 10 raised to the power minus 9 meter to 10 raised to the power minus 6 meter, that is between 1 nanometer and 1000 nanometer, then this is colloid. If the particle size is less than 1 nanometer, then this is true solution. And if the particle size is more than 1000 nanometer, then this is suspension. So now you got to know that in suspension, the particle size is very large. Fine. Like on some cough syrups and juice packs, you generally see it's written over here, shake well before use. Means shake it. Otherwise what will happen? If you allow it for some time, then it will become unstable. Means the heavy particles will settle down due to gravity. And if heavy particles settle down and then that solvent comes supernated, then what will happen? The phase will not be the same. That is heterogeneous. That's why suspensions are heterogeneous. While true solutions are homogeneous, they are very stable. Whether you allow it for 1 minute, 2 minutes, hour or forever, it will be stable. There will be no separation between the phases. While in case of colloids, it seems homogeneous. For example, milk. blood, it looks like homogeneous. अगर आप मिल्क को थोड़ी देर अगर रख भी सकते हैं तो आप देखेंगे कि पानी और मिल्क अलग अलग नहीं होता, जबकि अगर आप लस्सी में पानी मिला के थोड़ी देर रखें तो आप देखेंगे थोड़ी देर बाद पानी ऊपर आ जाता है और लस्सी नीचे रह जाती है. सो दैट इज हेट्रोजीनियस. बट इन केस ऑफ कोलॉइड्स लगता है कि होमो है, बट होता क्या है वो हेट्रोजीनियस. So though it is heterogeneous but still this is stable. Stable means there is no separation of the dispersed phase and dispersion medium. See why I am talking about dispersed phase and dispersion medium? Because in case of solution you see solute and solvent. Solute is the substance which is dissolved and solvent is the substance in which solute is dissolved. If I talk about that salt is dissolved in water, then salt is what? Solute, and water is what? Solvent. Similarly, in case of colloids, dispersed phase and dispersion medium are there. Dispersed phase is analogous to solute. Dispersion medium is analogous to solvent. So, in colloids, dispersed phase and dispersion medium are stable. They do not get separated on their own. Due to Brownian movement. What is this Brownian movement? Sir Robert Brown हुए हैं, British botanist. इन्होंने बोला कि जो पार्टिकल्स होते हैं कॉलॉइड्स के वो रैंडमली मूव करते हैं, zigzag motion. And what is this zigzag motion is called Brownian movement. So due to this Brownian movement, वो मूव करते रहते हैं against the gravity and they do not settle down. That's why the solution is stable. That colloidal solution is stable. If we talk about some transparency or looking through it, true solutions are transparent, while suspensions are opaque. Colloids are translucent. Examples are blood, starch in water, while here these are the examples. And in case of suspension, if you add soil, chalk water, chalk powder or sand, then that is soil in water, chalk powder in water, muddy water, that is sand in water, are the examples of suspension. I hope things are clear to you. See, watch this video twice, read the topic twice and then see the difference, right? So we'll see you in next topic. Bye bye.